All right, guys, I'm going to walk you through how to do some of these problems on the Nearpod. So the question on the left is what was in the Nearpod, and the picture on the right is what I typed into Desmos to get the graph. So I just literally typed in exactly what's here. So this guy and this guy match. And that's how I'm going to determine what's going on here. Now, I could look at the actual graph and I could tell that from the H here, which is going to be a positive 5, because when I'm with my X, I go the opposite direction. And then a positive 6 for my K, which is identified right here. I can already tell you that I've gone right 5 and I've gone up 6. I can also double check by looking at my graph and making sure that I go up 1 and over 1, up 3 and over 1, and up 5 and over 1 to stay on that graph. So the 1, 3, 5 rule is staying the same, which means that I can already tell you I'm not reflecting over the Y axis. I'm not stretching. I'm not stretching. I'm not reflecting. I'm also not stretching. I'm only shifting. So I'm shifting to the right 5. So right 5, and I'm shifting up 6. So this one should just be G and H. Okay, the next one asks me to sketch the graph. Well, guys, I already sketched the graph in the last picture. I put that into Desmos. So in order for me to duplicate this, I'm going to have to know that I've shifted to the right 5 and up 6. Because when I go into Desmos or into Savvis to graph this, it's going to ask me not for the vertex. It's not going to ask me to find a specific point. It's going to ask me for these shifts. So if you see that right here, it says vertical shift, horizontal shift. We just talked about that. Vertical is up and down. Our vertical shift here, guys, is 6. Our horizontal shift is this 5. It's to the right 5, so that's a 5. So when I plug that into Desmos, I already know there's no shrinking and there's no horizontal stretching. We just talked about that. When I plug that in to my Savvis page, it will change this parent function. Remember, this guy is the parent function, and it's going to shift it to over 6. And I'm sorry, over 5 and up 6. So it's going to shift it to right here, and it's going to make it go this way. So you have to know how to enter it in as well. All right, this one we've got to do that algebra because we got to find our A. So we start off with the equation in vertex form. So there's my equation in vertex form. Now I need to label each of my points. So I know my vertex is negative 5, 3, and it tells me that right here, vertex negative 5, 3. So my H is my negative 5, and my K is my 3. My X is a negative 4, and my Y is 1. So I got to plug all of those in. So I'm going to start with Y. Y is 1. That equals A that I don't know, X, which is negative 4, minus H, which is negative 5, squared, plus K, which is 3. Now, you may or may not know how to do negative 4 minus negative 5 quantity squared, so I highly suggest you use a calculator to calculate that if you're not sure. If you do know, you can do or change that to a plus, so that ends up being that 1 is equal to A times 1. Negative 4 plus 5 is 1. 1 squared is 1, so I really don't have to add anything on there. Plus 3. So this all turned into a 1. Okay? Now I'm going to subtract 3 from both sides, and I get negative 2 is equal to A. Well, that's all well and good, but I'm still not done with this problem. So to finish it up, I actually need to go back into this original equation. So Y equals A times X minus H squared plus K. I only replace 3 things. I replace A, H, and K. Now we already know H and K. H and K are negative 5 and 3, and we just solved for A, and A is negative 2. So all I'm going to do is plug that in. Y equals negative 2 times X minus negative 5, close parentheses, plus 3. Now, Pearson does not like you to put negative, negative, minus a negative. So if you don't change this to plus and make this negative 2 times x plus 5 quantity squared plus 3, it might count it wrong. So make sure you do that simplification process there. All right, so this one is not super hard. It asks for the transformation. So we have to write an equation, and the graph shows a transformation of a common function. So I have to write an equation for this function. It doesn't tell me what way that I have to put this in. So it doesn't say standard or vertex form, and since I want to work smarter and not harder, I'm going to do vertex form. So I need to figure out what this point is right here. And then I also need to figure out, does it follow the 1, 3, 5 rule? So is my A just 1, coefficient 1? So the thing that sucks is that there are no numbers, and I don't know why they would do that, but that's the way it is. So I've got to figure out this is negative 1, negative 2, negative 3, and negative 4, and negative 5. So that means that the y value here is negative 5. Up here I've got negative 1, negative 2, negative 3, negative 4, and negative 5. Here's my axis of symmetry that goes straight through. So that means my x value is negative 3. So that tells me this is h and this is k. So go back to that equation. Y equals a times x minus h quantity squared plus k. Now, do I follow the 1, 3, 5 rule? Do I go up 1 over 1? Looks like it. Do I go up 1, 2, 3, and over 1? Yes, it appears that that is working. So my a is kind of a moot point. This guy is just going to be 1. So now when I'm filling it in, I'm going y is equal to, I don't have an a, x minus a negative 3 squared plus 5. Now we don't like negative, negative, so remember that becomes a positive. So when you enter this into your test, you're going to make this x plus 3 quantity squared plus 5. All right, so we got to find the vertex of this parabola. Now I'm going to show you the long way, and then I'm going to show you a shortcut. So the long way is we've got to do all that work for the negative b over 2a. So h equals negative b over 2a, and then we have to find out what the y value is. So we've got to know that the a value here is 1. We know the b value is negative 4, and the c value is 3, which we really don't need c for this first part. So all I'm going to do is go back in and plug in negative b. So I'm going to actually erase the b, and instead of b, I'm going to put in what b equals, which is negative 4. And then on the bottom, I'm going to erase my 2. And instead of 2, I'm going to put in, or instead of a, I'm going to put in what a equals, which is a positive 1. So when I calculate that, I'm doing negative negative 4, which ends up being a positive 4 over 2 is equal to 2. Now, Desmos will do all that work for you. You don't have to calculate that on your own, or a calculator will. Just make sure you put it in correctly. This negative negative thing right out here, negative negative, is what people are going to get screwed up on. Then I'm going to plug in 2, so f of x equals x squared minus 4x plus 3. Well, I don't want x. What I want instead is I want what x equals, which is 2. So I'm going to erase every place I see an x, and I'm going to put a 2 in its place. So I'm going to take this and go 2, 2, 2, and I'm going to substitute it in using parentheses. Now, I highly recommend that you take this and put it into your Desmos calculator. 2 squared is 4. 4 minus 4 times 2, so 4 minus 8, and then we add 3. So when I plug that into my calculator, I get negative 1. So this equals negative 1. So my vertex is 2, negative 1. Okay, now I'm going to shrink some of this stuff, and I'm going to show you another way you can do it. Look at that, you all. I put it in Desmos. Guys, Desmos is our BFF right now. I plugged in exactly what was written right here into Desmos. And then I clicked on this little dot right here, and it showed me the vertex 2, negative 1. Isn't that what we just got right up here? We just got 2, negative 1. So you can use your calculator, your Desmos calculator, and do this in a lot quicker way.